Hey everyone, welcome to the 11th episode of the Coffee with CosmosDB series. If you have missed to join the last time, the session that we had, if you want to catch up on the recording, you can go to the playlist and then watch those previous sessions. If you would like to know about a particular feature or a topic, please reach out to us or you can discuss in the chat as well. Um, and also, if you're joining this session for the first time, this series is all about spreading the knowledge on Cosmos DB by the experts to the community members. So please make sure to subscribe the channel and share with the community members who are looking to learn more about Cosmos DB. If you're willing to present or volunteer to present on any topic, or if you have any feedback, please reach out to me. With that, let me introduce our guest for today. Today, we have someone from the engineering team for the very first time, who is actually working on the product. One of my go-to person when we talk about particular technology or the inventions that are happening these days, right? So, Rajesh, welcome, Rajesh. Rajesh, you are on mute.
Hi Saji, thanks
How are
for
you?
good. How are you?
Yeah, doing well. Yeah, thanks. Thanks for joining us. With that, why don't you go ahead and introduce yourself?
Sure. Hi everyone, my name is Rajesh Lumar. I work in Azure CosmosDB for PostgreSQL. It's an open source product called Citus. It's a distributed database, um, and I am in the engineering team developing a particular feature called change data capture, uh, shortly called CDC. So I So this is for observing the changes in a database. So change data capture is normally used uh, to observe the changes that is happening in a database from outside, right? Instead of issuing SQL queries and then get the data, so you would passively observe, right? So whatever happening in the database, you can be as a separate entity outside the database and still be able to uh, um, look at all the changes that is happening. Any rows getting inserted, any updation, deletion, all the events can be observed, and based on that, the application can do some action, right? So, for example, write an auditing application, which is sensitive data like a payroll data. So it could be very important that that payroll application can only be accessed by an authorized application, right? So even if somehow someone gets an access and then any data is getting changed, anything getting updated, then immediately that should that kind of an event should be detected and then some action may need to be taken. And also in a lot of cases today there are a lot of microservices, and one microservice may work in a particular data. For in an e-commerce application, there are payments, there is order, there is card, right? Everything could be a different microservice, and while you are developing the microservice, we may not know all the use cases possible, right? So uh, but tomorrow you can always develop another microservice which can look at what changes this particular microservice as doing in your database, right? So it can listen, and you can use that for migrating to another format, to another application, to another data, right? All that is possible. So that is what I'm trying to capture it in the in a simple picture. uh, if you look at Citus, Citus is a distributed database that there is a coordinator and then there are multiple worker nodes, right? Uh, so when you have a huge data, so for example, a sensor data from IoT devices, millions of devices that is coming across everywhere in the world, then all the data uh, will be streamed to a backend, and then you want to distribute it across multiple nodes so that you can still have a good read and write performance, right? So now the challenge here is right, the change data capture has been there for PostgreSQL for a very long time. It is based on logical replication. So Postgres already has the infrastructure for it. But what is special about here is that we are when the database is distributed across multiple nodes, right? For example, this sensor database, which is a distributed table here, has already been sharded across multiple nodes. Right? There's a worker node 2. I have given only 2 nodes here, but there could be hundreds of nodes also. So, how do you observe a change that is happening across all these nodes? Right? They are, though they are sharded and they are different tables, they all are logically belonging to the same. For the user, it is still a sensor data, right? So it doesn't matter whether it is from this shard or that shard or which node or which shard. It doesn't matter. But for an application, it looks like what happened here, right? And that is what you want to observe and you want to take an action, right? So, how this works in a technical point of view is all the changes that is happening in a database, right? Any change in any table, it will be written into a wall, right? What I have indicated here, it's a write ahead log. So any change that is not for CDC, but in general for the database operation for recovery and transaction uh, maintaining transaction, it will all the changes will get be written to the wall. And now there is a logical replication slot that the user can create, right? Because if the database contains hundreds of tables, we may not be interested in looking at all the changes in all the tables, right? So we will be looking for a particular change for this table, and even for a particular operation. We may not be worried about read. We may only be worried about writes and delete, right? So sensitive data. So then what we can do, you can create a publication for that particular table and for that particular operation you want, and then create a logical replication slot for it. Okay? So uh, one of the common examples of using such a mechanism, event-driven architecture, is using Apache Kafka. So what you can do, you can create a Kafka cluster with multiple Kafka brokers, depending on the scale that you need. So this Apache Kafka cluster using a connector, there are various connectors in the um, uh, Kafka ecosystem that you can connect it to multiple different databases, right? So for Postgres, there is a Debezium connector, and that Debezium connector can connect to your particular database and then your particular table that you want, and then get the changes you need, and it will be get broadcasted in the Kafka as a Kafka topic, right? So an application which has no idea, it need not even know that actually this data is coming from a database or change, right? It can work at a very logical level that any change that happens and I am listening to a particular topic, all the event will be get published to that topic, and the uh, application can listen to that and then take any action. So there are multiple use cases, right? It could be used for migration from one system to another system, and it can be used as a buffer between multiple related products, right? So, for example, a ticketing system which gets some user data that can be used by say marketing and other things, right? So, who wants to? So there is no direct relationship between these two products, but they can still exchange data between them using this mechanism. And yeah, so
Rajesh, sorry to interrupt. There is a question on the chat.
sure.
So I'm just highlighting.
Okay.
How are the changes across different shards ordered? Maybe you will address this later, or like, can you answer it?
Yeah, yeah. So right now the ordering is guaranteed since each of the changes goes to different particular node, right? So if there are multiple shards in one particular node, all those operations are written to the same write ahead log, right? So within one particular node, the order is guaranteed, right? So even if there are multiple transactions that is going on at the same time, so the database will order that and then put it into the wall. So since this particular mechanism using logical decoding, we read the data from wall, right? Not directly, right? So we get the exact event that happened in that particular node, right? But there is always a challenge that this is across multiple nodes. So there, the ordering across multiple nodes is not guaranteed, right? So that there is still a challenge there. There are various mechanisms that we are thinking of using a logical clock or using a distributed transaction. But that particular thing is there. But most of the time, we are we are looking at the logical change there, right? Not the exact order. What exactly the event that happened, right? So especially for analytics and auditing, it doesn't matter whether this happened in this node or that node or that node. You are logically looking at what happened in this particular distributed table, and because of that, what action I need to take.
Got it. I think there is a follow-up question on the same, like how is the audit guaranteed across multiple nodes? So I think
Yeah.
you answered that. Yeah.
Yeah,
Thanks.
that's what we talk about. If the order is really important, for example, you want to take this exact data and you want to replicate in the same way in some other cluster, maybe as a backup, then you can use timestamp. Yeah, all the events have timestamp. You can use that and then look at that. But today we don't have one way of doing that.
Got it.
So yeah,
There
so
is another question. Are you okay to take it up, or do you
sure,
want to
yeah,
take it
yeah.
up? So there is a question from Subhash. Is this applicable to any table or only distributed tables?
Yeah, yeah.
Can I do?
The reference table works the same way. Under the hood, it is a distributed table only, right? It is just that same data is getting replicated in all the nodes. So what happens is, if it is a reference table, then the consumer, right, the client application need to connect only to the coordinator node, because it will be broadcasted only from coordinator node, because the same data is getting replicated to all the nodes, right? Because you don't want to send the same data from all the nodes. Then if the consumer wants to read all the data, they will get duplicates. So in terms of reference table or any local table, right, it is not just for distributed table, it is for any table. You can create a publication for any particular table, and using the logical replication slot, you can always read the data, okay? So there is no restriction there. Distributed table, we needed a little bit more work to make it work, right? So because it is sharded across multiple nodes, and so that is the reason that we have to do some more work. But otherwise, the same is available for any particular table, reference table, local table, or anything.
Okay, thanks.
Um, so if there are no other questions, then I can go to
Yeah,
the
you can
demo.
proceed. Yep.
Okay. Right. So uh, just to give you an overview, I am showing you a SQL session that I have created across multiple uh, nodes in a Citus cluster. So in my case, 9700, right? So I am running multiple Postgres in the same node that it's a laptop. So I am running multiple Postgres nodes in multiple ports. Localhost 9700 is my coordinator, and localhost 9701 is my worker node 1, and 9702 is my worker node 2, right? So this is Citus cluster. So what I want to demo is how do I, from a table that I have created, for a simplicity sake, I just created a very basic table. It's an employee table, right? Uh, so, so it's the employee table. It just has two columns. One is the ID, that is the employee's ID, and the other is the employee name, right? So this table that I have sharded, I have created it as a distributed table, and you can see that there is one shard here in worker node 1, and there is another shard here in worker node 2, right? So these two combined gives the distributed table. So what I have done is I have created a publication for this called employee publication, right? So, so you can see this. You have an employee publication, and it applies to this particular table, employee table. And then I for all the operations I have enabled it, right? So you can create it for a particular operation. I will show you the command that with which I created. This is the command. So pretty simple. Any distributed table that you need to create, you want to enable the CDC. All the user have to do is do this: create publication and some publication name for which table, right? In some very rare cases, you can do for all tables, but there are some issues there, because if you give all tables, then even the system tables will get published, right? Usually you don't need to do that. So you want to create a publication for exactly that particular table, or number of tables that you want. So once you create this publication, so this is enabled for CDC, right? So after that, you can create a. In my case, I have a local Kafka cluster, but in the users can use it a Docker based container for Kafka. And most of the cases in production, there will be already a Kafka cluster, and you can just use that, right? Uh, One more thing that you have to do to enable Kafka is if you go back to the diagram. So if you see the diagram, Sajid, can you go back to the
Yep.
PDF?
Yeah, I'm highlighting that.
Okay. So what I want to show, right? Because if I just show it in the console, it will be confusing. You can see that I have mentioned Debisim connector 1 here, Debisim connector 2, Debisim connector 3, right? So what does it mean is that the database operations are available in the write-ahead log, right, in each node, and Kafka is running separately, right? How do you publish the changes from the database to the Kafka? This is the connector that is being used, right? The connector understands both. The connector knows how to get the data from write-ahead log and push it to Kafka, right? So this DBSim connector is an open source project, and it has been there, and it is available for multiple databases, MySQL, Postgres, everything. So for the Postgres DBSim connector, you need to give some, because this DBSim connector doesn't know, right, where is our database, what is the credentials to connect, and all that. So that those information need to given in a particular configuration file. Uh, I will show later what are all the settings that needs to be done. So maybe I can show it in the console. Uh, okay. So there are some settings. For example, you have to give database username, password, everything, and all that will be using that. The DBSim connector would connect to the database and get the events. Right, all the data will be taken from that and then pushed to Kafka. Right. Let us see that in action. Okay, so I have created the employee table and I have distributed it, right? So now here I am running the Kafka cluster, right? So this is the Kafka, this is the zookeeper first you have to run, right? Which will be the all the metadata of the Kafka is stored there, and then we are running the Kafka server here. Okay, so these two are just the infrastructure components which most likely will already be there. Okay, and what more we are doing is for the Debisim, right? So you see, we need a Debisim connector for each worker node, right? Because the database has been distributed to multiple nodes. For we have to run multiple Debisim connectors for each node, right? If there are 10 nodes, then 10 Debisim process have to be run, and that is actually taking the data from the database and then pushing it into the Kafka, right? So for example, let me insert a new data here. So right now, I have 100 records. So I give just 101. Okay, I insert a new record now. So I have inserted a new record. So this event, you can see that I am running a Kafka console application. So this gets all the data right from the Kafka, right? It is looking at the Kafka server that is running here, and this is the topic that it is listening to, right? So there may be multiple applications running, listening to multiple tables. Right? This one particularly listening to the employee table, and now you can see that whatever data that I have inserted, right? So the before is null. That means it's a new operation, right? The operation is C, right? So it's a create operation. So before is null and after is ID is the 101 data I gave, and the name is the new name that I have given, right? These are all the metadata, right? For which database at what time, right? So for the other question, right, how do you know how to order? One thing you can do is you can look at this timestamp and then look at order. Right? It may not be a perfect solution, but for most cases this is enough if the ordering is important, right? And so let me. So if you see here in the create the insert case, the before will be null and after will be the actual data, right? So let us update some data. So I will change it to for the same row that I inserted. Let me change the name employee name to Rajesh. Right? So this update event now comes to here. So what happens? You can see that before uh, case it is ID is 101 and name is test name, right? Originally what I inserted, and after I have updated, the ID is 101 and name is Rajesh, right? And the other is like the metadata, right? To know that what event when it happened, which DB, what schema, and everything will come there. Okay. So I will show a Java example also later. Uh, so yeah, let me do a delete operation. Right? So I am going to delete whatever record that has more than 100. Right? This is right now only one record, so that will get deleted. This row will get deleted, and in this case you can see the before is this, right? That is ID 101, name is Rajesh, and after will be null. That means that this operation is deleted, and you can see the operation here also. Operation is delete, right? In this case, operation is update. For- And for insert, the operation will be C. For update, the operation will be U. Okay. So this is basically the crux of it, right? So how to do from how to create a subscription and then listen to a event from a particular distributed table, and it could be multiple distributed table also. That is also will. And the same procedure can be done for reference table also. Right? In that case, you don't need to create multiple connector. Just connecting to the coordinator alone will be enough. Okay. Let me show some configuration files. Just a second. There are multiple configuration files. Right? For each Debezium, you have to create a Debezium connector properties here. So here, we are connecting to the worker node 1 here, and this is the database, right? The database DB name, and this is the DB test server topic, right? That is the topic that I used here to listen to the events. Right? Yeah, that's all. So there is, so however many nodes you have, however that many connectors you need to create to do that. But when the main thing is it doesn't matter from which node the event comes. You can see that all though the event actually happened in a particular shard, right? The table will come as as a employee table only. So each data that I inserted will actually get inserted to this table, right? This particular shard table, right? It could be in this node or that node, but for the application, it still comes as a employee table, right? All the events from the write ahead log, that particular operation gets translated to as a event that happened on the distributed table, not on the local table. It's a shard table, right? Uh, any questions so far?
No, there are no questions from the chat.
Okay. So yeah, then let me just for briefly stop the sharing, and I will share my Java application. Okay, is it visible now?
Yeah, I can see.
Okay, so
There is a question from Subhashis again. Let me
okay,
highlight.
okay.
It's a long question, so probably
Uh, uh, is this specific to a single region deployment currently, or single region right in a multi-region deployment, or multi-region right in a multi-region deployment? I am not sure if this is for the Postgres or Cosmos DB, right? So this is a Cosmos DB for PostgreSQL, right? In this case, there is not multi-region, multi-master kind of scenario. There could be only one writer, right? So um, uh, actually the concept is simple, right? Every worker node, you make a connection to your, that particular node and for that particular table, and then get the event, right? The same can be extended to multi-region also, right? It doesn't matter. Maybe there may be a little bit of delay, because if you go cross region and then try to listen to the event from DB hosted and another region, it may be a little bit slow. But other than that, the concept is same for either it's a single region or multi-region. It works the same way.
got it.
Let me go back to this. Uh, so here, similar to what we have done in the command line. So basically, what you need to do is you have to specify where is the Bootstrap server, right? That is where is the Kafka server running, and you can give a topic to it, right? Which topic that you are listening, right? And then you can set the properties, right? What will be your key and what will be your value, right? So that if you look here, all our keys are strings, right? And values could be a string also. So we just specify that, and then you can start a Kafka consumer using these properties, and you can poll for the data, right? So it will be keep on polling the events from Kafka server, and then any data that is you are getting, so you can interpret it in whatever way you want, right? So basically all that sends is a JSON data, right? So as long as you know what is the schema, you can always look at this particular JSON, uh, deserialize it, and then set it into your own object and use it. For example, this ID 100 name is an employee JSON. So you can the user can look at one particular column that they are interested in, or all the data, right? And they can also know which operation that has happened, and based on that you can take an action. Okay, so yeah, and the other thing is the similar thing can be from the status table with the distributed database across multiple nodes. If needed, the user can use this mechanism to migrate the data to a Postgres also, right? So the mechanism is similar. You can have multiple subscription from a Postgres database to all these nodes from coordinator and multiple worker nodes. Each subscription is done, and then once that is done, then all the data from the original nodes from coordinator and other worker node will flow to the Postgres. So from the distributed table, it can be translated into a one single table also. Of course, it has to be done carefully, because if there is a lot of data, multiple nodes has a lot of data, and then if you try to subscribe from a node which doesn't have that much of capacity, there may be problems. So that has to be done carefully. But if required, that this can be used as a mechanism for migrating the data. Any other questions?
No, I don't see anything in the chat.
Okay.
Uh, Instead of Kafka, what are the other ways that we could use? Like,
Yeah, there are other things like Pulsar is there, and
okay,
also people use it. This can also be used as a permanent storage, right? So you can take all the changes. For example, you are getting the JSON data, and you can push those things to say in blob storage, or for later analytics or other things, right? So I see that recently with the AI getting popular, people are using Citus and Postgres, right, for vector databases. So in case of vector databases, where you are storing the representing strings in a different combination, so this can be used, right? The CDC mechanism can be used to feed the data, right? Whatever happens changes here into a ML model also. So people are using that.
okay. There's a question from the chat aligning with what I have asked. Like, can we use Spark streams instead of Kafka?
Yeah,
And then do you need durability of Kafka?
yeah. The durability is important. So the Kafka cluster, right? So it depends on the use case, right? For example, if you want only using it for migrating the data, right? So until the migration is done, we need it, right? After that, this that cluster may not be required. But if you are using it as an event-driven mechanism, right, from one microservice to other microservice, until the other microservice has read the data, you will have to endure it, right? So depending on the use case, the Kafka durability needs to be configured. And
Got it.
other question, like the mechanism is from the Postgres and Citus side, we are exposing the data, right? You are creating a publication, you're creating a logical application part, and using that anybody can read, right? The Kafka is the most popular thing, but Spark has a connector also. Using Spark also you can do. So
Got it.
Kafka is just giving you a good abstraction, right? So for example, right, I showed the client application, right? It's just a few lines, and then you can consume the data and use it whatever way you want.
Okay.
But
Yep.
it could be used for any framework.
Got it.
And we are working on few things, right? So for blob storage, sharing and all, but uh, right now it is available for open source community for it's a preview, so people can use it and give us feedback and use
Okay.
it for the migration.
Do you want to talk about the roadmap, or is it like we can cover
It's
it
still
later?
not still in the discussion phase,
Okay. Got it.
but it's a heavily developed feature and definitely it will be expanded more.
Got it. Okay. I think if that's all that you wanted to share, I don't see any other questions in the chat. Um,
Okay,
Thanks for all the questions, whoever have asked those questions. And thanks, Rajesh, for your time and for sharing
thanks
the
again.
beautiful demo.
Thank
Um,
you.
Before I close, make sure to subscribe the channel and please do provide feedback. If you want to hear about a particular topic, reach out to us. I will be able to accommodate the particular topic that you want to talk about. And in a couple of weeks, we will have another session on the security side by another PM from the Cosmos DB team. Yeah, we will meet again in a couple of weeks. Thanks, Rajesh. Have a good day,
Thank
everyone.
you.
Bye.
Thanks.